this question here, we're looking at a population growth model, again using this idea of exponential equations. And we have a template to model populations over a certain period of time. So this is some relatively old information about the population of Newmarket. In 1990, it was 45,500, and in 2010, it was 85,000. How can we use that information to, first of all, write an expression for the population growth to model it, and kind of find out what it would be in 2020, which is last year now, but we can extend that, see what it would be like in a future year as well, but we'll stick with 2020. So our equation for population growth is given by this template here, where P of t is the population for at a given time t. In years, P of 0 is the initial population, wherever you're measuring it relative to, and B is the rate of increase, and T is the amount of time that has elapsed since you started measuring the population of a city or something. So let us put this information, toss it into an equation, and see what we get. So I'm going to write here P of t equals, well, my initial value was 45,500. And my population rate, the rate of increase, well, we have to figure that out, okay? So I'm going to write B there for now. And T is the amount of time in years that has elapsed. Okay, now, if 1990, consider that like your year 0, the year 2020 is going to be, sorry, not the year 2020, 2010. 2010 is going to be 20, okay? That's 20 years after 1990. So if I'm trying to find what my B value is, and I plug in, let's say, 20 over here, I know that my population after 20 years, relative to 1990, is going to be 85,000 people. So what I have here is an equation that I can solve using methods that we do know. So I'll begin by dividing both sides by 45,500, 45,500, cancel. And on the left-hand side, I'm left with 1.868, and that is going to be b to the 20. My b value will just be the 20th root of 1.868. And if you do the math, you end up with 1.037. So that's a population growth of roughly 3.7%. Okay, so my equation, and let me kind of shrink this a bit. My equation now, I can rewrite it in such a way that I have my population growth rate in there. So I'm going to write P of t equals 45,500 times 1.037 to the exponent t. And we can use this now to find the population approximately in 2020. 2020 is going to be 30 years after 1990. So I'm going to go P of 30 equals all of this stuff to the exponent of 30. And what does that give? Well, after doing some calculation ahead of time, I get 116,041. And that's approximate, it's not exact, but it seems reasonable. Okay, again, 3% a year, that sounds